Good. Good evening, Professor. My name is Wilson Okafor, and I have with me.
Thank you, Wilson. Professor, my name is Junior Emmanuel, and we'll be taking you down our project's topic and the assignment that was given to us as a group. Wilson, as my pair, we decided to pick the closest pair problem solving using brute force, divide and conquer. And the instruction we have is to use a data set with at least 1,000 records, which we have executed and implemented in our code, which will be running you down shortly. This project basically solves the closest pair problem using two approaches, the brute force and the divide and conquer. Now, in this idea, we just wanted to make some, try to compare every of this pair of the points to find the pair with the smallest distance algorithm, right? So for each of the points, we'll calculate the distance for each of the points, then they will try to track the minimum distance and the corresponding pair. Then we return the pair with the smallest distance to be the better one. Then the divide and conquer approach talks about the smart method to cut the points into half, recursive or compares necessary points at all. So the algorithm behind this is just to make sure that we have it sorted. Then after sorting it, we use the coordinate level from coordinate X to coordinate Y to sort this. So basically speaking, this topic is very important because it has a lot of it's very important because one, it reduces the clustering nature of our calculation and coordinates, right? It helps us to show many real world scenarios such where you see trying to get group similars that point out together customers in terms of buying and the habits of buying and selling, right? So it also helps us to understand the pattern recognition that has to do with finding close relationship between the features of images, like in terms of facial recognition or fingerprint matching. This helps us to identify those things. And in terms of another very important aspect is geography mapping, graph mapping of a thing, finding two cities, stores, or facilities that are nearest to each other. This helps us to build this understanding, and in terms of network, it helps us to identify the distance measurement and this. So how we solve this is using brute force, we compare every possible word and stuff like that. So we're going to run you down our code to see what we've done and how we're able to execute this to come up with the shortest distance. And Wilson will run us down that, then I also make my contributions. Thank you, Wilson.
Thank you, Ma, for such an insightful introduction. So the first thing we did was to load the data set. So first we loaded the data set using pandas. I'm using IntelliJ IDEA for this. And so we read this CSV file that contains points with X and Y coordinates. We also just add error handling, if the data set doesn't have the correct, curriculum or it's empty, the program raises an error and stops to avoid just to avoid crashing later. So now the first one was to convert data frame to list of point tuples. So after successfully loading the data, we converted it into a list of tuples. Each tuple represents a point in 2D space. Right, this makes it easy to calculate uh, distance between points, right? So then we defined a function to calculate the e e Euclidean distance between 2 points. It simply just applies the Pythagorean theorem to find the straight line distance between two coordinates, right? So the brute force algorithm, we first implemented the brute force method. It compares every um, possible pair of points, calculates the distance and also just keeps track of the smallest one found. Although it's simple to understand, it's very slow because it has a time complexity of big O n, squared. And then we then Okay, so then the divide and conquer algorithm. So what did we do here? We also just implemented a faster divide and conquer method. It sorts the points by, by X and Y coordinates first. Then it just recursively, divides the data sets into two halves, finds the closest pairs in each half, and then checks a narrow strip near the middle line. Only a small number of points, about 6 or 7, are checked in the strip, making the algorithm much faster, big O n log n time. So I'm going to hand over to Emma to continue with the time brute force.
Thank you, Prof. If you look at our code, you see the time brute force in our code. One of our code line here, you see we're talking about the time brute force. Now, what we try to do here is we try to measure the execution time, right? I mean, the time complexity for the brute force method. We try to find the closest pair by, taking the longest distance in terms of seconds, right? We try to take that in terms of seconds. So this help us to understand the time complexity of our code, help us understand the closest pair in the coordinates that we implemented earlier, like Wilson said. Now, if you go down the code, you're going to see where we talk about time, divide, and conquer, which is part of what we're supposed to be talking about. Now, what were we able to do in this part of the code? We also try to understand the methods in which time is being divided, right? And once we divide it, how do we conquer it? It finds the same closest pair, but this time it goes in a faster way, right? So the approach is to locate the fastest closest pair using the same category of seconds. So in our code, we discovered 0.004 seconds in the brute force, while in the time divide, we use 0.0025, which is a shorter time compared to what we have in the brute force. So this to us already is saying that, okay, this is the closest pair for you to adopt.
Yeah.
However, if you check our code, you see that the outputs and the results that we have after our programming prints out the results, and it shows the closest pair found by each of these methods, the distance and the time each of the method took, right? This shows us that, okay, reliably, there is a time that's after doing the comparison, there's a time that is more efficient. This also print the same as the first people is just by checking it and knowing which of them gives you the accurate time, which of them gives you the shortest time, which of them gives you the closest pair. So that's what we're able to do. And I mean,